Hello viewers, welcome to today's session. In today's session, we are asked to solve this question. But before we start this session, kindly follow our page and subscribe for us to promote this video. Now let's see how we are going to solve this question. We are given this question to show that B, the given set, is bounded, and hence we have to find in B and then sub B. Now let's see how we are going to solve this question. We have 1 plus 6x plus s squared on 1 plus s squared. So I will let a certain variable represent this whole function. So I will let this one equal to y. Then I will look for the values for y. Let's see how we are going to do this. I'll just do cross multiplication. So I'm going to have 1 plus 6x plus s squared is equal to y, 1 plus s squared. Now here I'm going to have 1 plus 6x plus s squared is equal to y plus ys squared. Here, let's group like terms. I'm going to have s squared here minus ys squared plus 6x plus 1 minus y is equal to 0. So let's factorize the variables of x in terms of quadratic equation. So we are going to make this equation looks like what? Quadratic equation. So this is what we are going to do. Here I'm going to factorize the value for x squared out. So I'm going to get 1 minus y here. Plus here I have 6x plus the constant term which is 1 minus y. So we can see in terms of variable x, this equation is looking like quadratic equation. Now, how are we going to solve this question? You see, having equation, quadratic equation to solve, we can check for the roots of what the equation, and we have three discriminants. We have the discriminant b squared minus 4ac, which is equal to 0. That means when we are having a rare repeated root, and the discriminant b squared minus 4ac, which is greater than 0. That means when we are having a real distinct root and the discriminant b squared minus 4ac is less than 0. When you're having what? A complex root. But the question is saying that since x is a member of real numbers, it means that we are not going to get this type of root. We're not going to get what? A complex root, but rather we are going to get either a real repeated or real distinct root. So for us to quote our discriminant, we need to fuse a real distinct and then a real repeated roots together. So I'm going to use the discriminant b squared minus 4ac is either greater or equal to 0. So I'll write here, since x is a member of real numbers, then I'll quote this one as my discriminant. Now let's see how we are going to solve this one. Looking at this equation, when you compare this one to our quadratic equation, you can see that our a is equal to 1 minus y, our b is equal to 6, and our c is equal to 1 minus y. Now let's do a substitution. I'm going to have b squared, which is 6 squared, minus 4 times a, 1 minus y, times c, 1 minus y, should be greater or equal to 0. Now what is c squared? C squared will give us 36 minus 4. So here I'll have 1 minus y all squared is greater or equal to 0. Now let's see. Here we can divide 2 by 4. So I'll have 36 on 4, which is 9, minus 1 minus y all squared greater or equal to 0. So here I'll have 9. Let me expand this bracket. I am going to get negative. Here will give me 1. 1 squared will give me 1. 2 times 1 times negative y, which will give me negative 2y. Then plus negative y squared will give me y squared. Is greater or equal to 0. Now let me multiply 2 by negative. I'm going to have 9 minus 1 plus 2y minus y squared is greater or equal to 0. So here I'm going to have negative y squared plus 2y plus 8 is greater or equal to 0. So this place, I can multiply 2 by negative 1. So here, we are going to have, we can multiply this one 2 by negative 1. So that we are going to have y squared minus 2y minus 8 is less or equal to 0. Since we multiply 2 by negative 1, the inequality sign will change. Now we are going to use the quadratic formula y is equal to minus b plus or minus square root of b squared minus 4ac on 2a. So I'll have y which is equal to, the b is negative 2, so minus 2 plus or minus square root of negative 2 squared minus 4 times a, which is 1, times c, negative 8, on 2 times 1. So I'm going to have y which is equal to 2. Here will give me 2 plus or minus square root of, here will give me 4. 4 plus this place, which is 32. I'm going to have 36 on 2. And square root of 36 is 6. So I'm going to have y is equal to 2 plus or minus 6 on 2. So here, we are using the inequality less than or equal to. So here is less than or equal to, less than or equal to, and less than or equal to. So here, let me change it to less than or equal to. But we are having two conditions. Y is less than or equal to plus or minus. So with this condition, we can say that y is either greater or equal to 2 minus 6 on 2, and y is less or equal to 2 plus 6 on 2. So this is what we are going to have. And what is 2 minus 6 on 2? What is 2 minus 6 on 2? Which will give you negative 4 on 2. So I'm going to have 2 minus 6, which is negative 4 on 2, which will give me negative 2. And 2 plus 6, which is 8 on 2, which is equal to 4. So here I'm going to have y, which is greater or equal to negative 2 and is less or equal to 4. So having this way, it means that we are having the inf of b as negative 2 and sup of b as 4. Since we are having the infimum and then the supremum of set b, hence we can say that hence set b is bounded. So thank you for watching this video.